Hello and welcome to my channel. This is a fully functioning project using the expressive ESP32 and many other component modules. The personal help system is a great worthwhile project with a real use. There is always someone out there that needs help. It might be you, or a family member alone at home and has fallen or taken ill. It is not always possible to use a mobile phone, and often in certain situations it is impossible to do so. You might be a shopkeeper with staff that are often alone out front and they may need help with the situation, and they could just press a remote button in their pocket to get assistance. I can think of many situations where the personal help system would be of enormous benefit. This is video number 2 in my personal help system series. Please see my previous video for the full introduction into the personal help system project and how to set up the Arduino IDE for the ESP32 microcontroller. Although it is not necessary to use a buck converter to regulate the power for your ESP32 alone, as a good USB cable will suffice. It is however necessary to regulate the power for the personal help system's other components and is an important step into the project. This buck converter will provide regulated 5.1 volts up to 3 amps regardless of the incoming DC voltage, which must be within the LM2596 specification. Never take it to its limits. The personal help system and the ESP32 require a constant power supply to avoid brownouts. This is when the voltage drops below the acceptable working limit of the device, causing it to restart. In this project we will be using the LM2596 based buck DC to DC converter module. Buck means step down. So the incoming voltage must be greater than the outgoing voltage by at least 1.5 volts. The buck converters will maintain a previously set voltage regardless of the incoming voltage, up to 40 volts DC. But again, never take it to its limits and stay well below the 40 volts. We will set our buck converter to 5.1 volts with the input supply coming from a 9 to 12 volt, 2 to 3 amp DC power supply. Make sure nothing is connected to the output terminals of the buck converter before you begin. To adjust the buck converter, connect the DC power supply to the in terminals. Then, connect a voltmeter across the out terminals. Turn the potentiometer screw clockwise to increase the voltage, and anti-clockwise to decrease the voltage. The potentiometer has a long throw and no end stops. It will just click if at its ends. You may have to turn the screw many times before the voltage begins to change. Finally, adjust till it is at 5.1 volts. Always double check before connecting to any devices. The buck converter can handle up to 3 amps, so ensure you use a suitable wire size and solder them to the terminals. DuPont wires are not suitable. In this image you can see the 2.4-inch TFT display. This one does not have the touch screen. In this project it is not required. In this image you can see the reverse of the 2.4-inch TFT display. The connection pins are on the left. The top 4 connections are not used as they are for the touch screen. We only require the bottom 8 connections. We will now connect and configure the 2.4-inch TFT display with the ESP32, which forms a key part of the personal help system project. The ESP32 and the Arduino IDE require 3 libraries: the SPI Serial Peripheral Interface Library, which is included within the Arduino IDE, the Adafruit ILI9341 library, and the Adafruit GFX library to drive the TFT display. The last 2 libraries are provided by Adafruit. Their web address is in the description below, and these libraries need to be installed into the Arduino IDE. Follow the on-screen instructions below to install them. Please pause the video while you do so. Go to Tools, then Manage Libraries, and in the search bar, type Adafruit ILI9341. If the library is already installed, then it will say so. If not, then click on Install and wait for it to install. And again in the search bar, type Adafruit GFX. If the library is already installed, then it will say so. If not, then click on Install and wait for it to install. The 2.4-inch TFT display uses the SPI bus to connect with the ESP32. The connections used for this are suited to this particular project but should work for most projects, as you will see. The breadboards mentioned in video 1 will now come in handy. The connections are as follows. From TFT to ESP32. VCC to 3.3 volts. Ground to ground. CS to pin 15. Reset to pin 0. DC to pin 23. MOSI to pin 13. SCK to pin 14. LED to pin 4. Once all these connections have been made, then your ESP32, TFT display and buck converter should look something like this. Don't worry if it doesn't, the important thing is to get things working and tidy up later. Okay. So now the TFT display should be correctly connected to your ESP32. It won't work just yet, as we need to upload a sample Arduino sketch to configure it. The link for the sample Arduino sketch for the TFT display is in the description below. The sketch is too long to display here, so head over to your Arduino IDE, open the sketch and upload it to your ESP32. The sketch will set the correct parameters for the Adafruit ILI9341 driver, as below. And I have provided some great display functions for you. In the next video we will be looking at the DS3231 real-time clock module and connecting it with the ESP32 using the I2C bus. I hope you enjoyed this video and found it interesting. If so, please consider clicking subscribe and click the thumbs up to say you liked it. That would be much appreciated. Clicking subscribe will let you be the first to see the next and my other videos. There are many more interesting projects to come. So please stick around. And I will see you in my next video. In the meantime, keep learning. And thank you for watching.